Hello class. Now today's video we will discuss about class 10th maths chapter 3 pair of linear equation in two variable. This is the introduction part 2. My previous video, the introduction part 1, we have discussed about what is linear equation into two variable, that we have discussed also in class 9th chapter 4. Okay, so here is a pair, it means here is a two lines. Okay, two lines, that is a linear equation in two variables. Okay, so what we have discussed in our earlier videos, we have discussed about there is a class ninth, a linear equation that is in the form of x plus y is equal to 6. Okay, and we have done in a class ninth graphically. Okay, and algebraically also we put the value of x and we got the value of y, that is an infinite number of solution. Okay, if the single, if there is a linear equation into two variable is only one, that is x plus y is equal to 6, it means it has a infinite number of solution. But when we talk about pair, when we talk about pair, it means in a graph, in a, when we plot a graph in a plane, there the two lines, it means the two lines are a straight line. If they are in a two lines in a straight line, it may be then they intersect at a point, they, it may be they are parallel, it may be they are coincident or overlap. Okay, so now here, sorry, here we will do, here we will discussed about, there will be a two straight line in a plane, only one of the following three possibilities can happen, only three possibilities can happen. The first is two lines will intersect at a point, two line intersect at a point, so two line intersect at a point. Okay, that is o, that is o. Okay, they never intersect at any point, they never intersect at any point. Okay, now the single, the this one is a third one, two lines will coincident, that is overlap. Two lines will be coincident, two lines will be coincident, that is overlap. Okay, so these two lines are coincident, it means uh, two two lines are overlap each other, so three possibilities are will happen. Okay, so let us discuss three possibilities by our example. Okay, so let us take the example first. Example first. Example first. Example first. So the first example is, we take y is equal to 1 by 2x. Okay, and 3x plus 4y is equal to 20. It means 2y is equal to x. Okay, so now here 3x plus 4y is equal to minus 20 is equal to 0, and this can be written x minus 2y is equal to 0. Okay, so these two are equation 1 and equation 2. So by now comparing comparing equation 1 and 2 by comparing equation 1 and 2 by equation ax plus by plus c is equal to 0. Ax plus by plus c is equal to 0. Here what you have done this, so here you can write it, here you can write it, uh, we discuss here, we discuss here, here algebraically, algebraically and geometrically, where we discuss here algebraically and geometrically. Okay, So when we compare with ax plus by, so what we have done, so this one is our ax1, so a1 is equal to, so what you have right here, a1 is equal to 1, b1 is equal to -2, and c1 is equal to 0. Okay, now here a2 is equal to 3, b2 is equal to 4, and c2 is equal to -20. A2 is equal to 3, B2 is equal to 4, and C2 is equal to -20. Okay. So now this is A1, A2, B1, B2. Okay. Now we are ratio. We are now putting taking a ratio. So A1 upon A2 is equal to 1 minus 2, and B1 upon B2 is equal to -2 upon 4 is equal to -1 by 2. Okay. Minus 2 by 4. Is it? So -2 B1, and here is -4. So what you have seen here. So A1 is equal to 1, B1 is equal to -2, C1 is equal to 0, A2 is equal to 3. So sorry, I'm confusing here, but A2 is 3. A2 is 3. A2 is 3. So here A1 upon A2 is not equal to B1 upon B2. What we have, this is our result. This is our result. This is this is our result, algebraic result. This is our algebraic result. This is our algebraic result. This is our algebraic result. Okay. Okay. Now here, now take a solution of equation 1. So here we take a solution of equation 1. Okay, equation 1 solution. So what we have got, x, y, for equation 1, for equation 2, for equation 2. Okay, equation 2. So now we are putting here, when we put the value of x is equal to 0, x is equal to 0, y is equal to also 0. Okay, when x is equal to 2, x is equal to 2, y is equal to 1. When x is equal to 4, y is equal to 2. Okay. Okay, now here x and y, when x is equal to, so what we have done here, so here done we done here, what we have right here, y is e4, y is equal to 20 minus 3x implies that y is equal to 20 minus 3x upon 4. 3x upon 4. Okay, so when we put the value of x is equal to 0, okay, so what, so this portion becomes 0, and 4 5 ja 20. Okay, so let us do 3 2 ja 6, 3 2 ja 6. No, we are not here 6. So what we have put here, we had put here 4, 3 4 ja 12. What is 8? 4 2 ja 8. Okay, so now 6 6 3 ja 18, 1 by 2. Okay, 1 by 2. Okay, so let's do the graphically now. For graphically, so now here, so plot a graph, plot a graph. So now here, so what the maximum is number is 6. So on a x-axis. So I am here taking x, x dash, y, y dash, 1, 2, 3, 4, 5, 6, x. Okay. 1, 2, 3, 4, -1, -2, -3. Okay. -1, -2, -3. So x is equal to 0, y is equal to 0. Okay. 2, 1. So here is a 2, here is 1. It is 2, 1. Okay. Next 4, 2. Here is a 4, here is 2. 4, 2. Okay. So now 4, 2. Okay. Next 0, 5. 0, 5 is here. 0, 5 is here. 0, 5 is here. 4, 2. So 4 is here, 4, 2 is here. So again, so 6.5. 6.5 is here something. 6.5. So here the intersect at. So this is graphical. This is graphically. It is graphically. Graphically, I am writing here. Graphically, graphically, both lines, both lines intersect each other, intersect each other, intersect each other at one point, one point. So it has one solution. So it has one solution. It has one solution. Okay, that is unique. Bracket is unique solution. Okay, it is unique solution. And algebraically, what is a1 and a2 is now this is a graphically, and algebraically a1 upon a2 is not equal to b1 upon b2. Okay, this is algebraically a1 upon a2 is not equal to b1 upon b2. What we have observed from the example 1. So I have taken example 1, x minus 2y is equal to 0 and 3x plus 4y minus 20. Okay, so now algebraically we have observed that the ratio of a1 upon a2 is not equal to b1 upon b2. Okay, is not equal to here a1 upon a2 is not equal to b1 upon b2. Okay, b1 upon b2. So now here a1 upon a2 is not equal to b1 upon b2. So this is algebraic result. Now when we take a solution of these three points, now we have observed that, so when we plot a graph of the equation, what they have intersect at a one point. So we have said that if a two lines intersect at a point, then its algebraically a1 upon a2 and b1 upon b2 are not equal, and graphically they intersect at a point and we have a unique solution. Okay, so let's ask the example number 2. Example 2. Example 2. So I will take the example number 2. So what we have take here, x plus 2y is equal to 4. Now I am in partition, it may make confusion me. X plus y is equal to 4 and 2x plus 4y is equal to 12. Okay, so now first of all you we compare with the compare with compare compare a1x plus b1y plus no, first of all you will write here just like we write here solution, oh sorry, this x plus 2y minus 4 is equal to 0, and 2x plus 4y minus 12 is equal to 0. Okay, so now here compare with a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. Okay, so now compare with, so a1 is equal to 1, b1 is equal to 2, and c1 is equal to minus 4. Okay, now here a2 is equal to 2, b2 is equal to 4, c2 is equal to minus 12. Okay, c2 is equal to minus 12. Okay, so now take a ratio. So now taking ratio, a1 upon a2 is equal to 1 by 2, b1 upon b2 is equal to 2 by 4, it means 1 by 2, and c1 upon c2 is equal to minus 4 upon uh, 4 upon minus 12, it means 1 by 3. So what we have observed algebraically, so here a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Okay, okay, so let us again, now here graphically, so this is algebraically algebraic result. Now graphically, now graphically, so first of all graphically take a solution. Take a solution is 2y is equal to 4 minus x. So y is equal to 4 minus x upon 2. So here 4y is equal to 12 minus 2x. So y is equal to 12 minus 2x upon 4. Okay, so when we 2 is common, so 6 minus x upon 4 is equal to 6 minus 2. 6 minus 2. 6 minus 2. Now we have a making a solution. So x and y. Now here is a solution. X and y. So here, when we put here x is equal to 0, y is equal to 2. Okay, when x is equal to 2, so 4 minus 2 is 2, so 1. When x is equal to 4, 4 is 0. Okay, so now here, x is equal to 0, so y is equal to 3. Okay, when we put here 4, So what is x minus 6 minus 4 is 2. So 1. When we put here 6, so when we put here 2, so this is 6 minus 4, 2 is 4. So 2 2s are 4. Okay. So now plot a graph. Plot a graph here. So what we have, x, x dash, y, y dash. So now here 0 0. Okay. So now 1 2 3 minus 1 minus 2 1 2 3 and 4, because maximum is 4. Okay. So now here 0 2. So 0 x axis and y is 2. Here is a 2. Okay. So now again 2 1. 2 is here, 1 is here. So again 4 0 4 0 is here. Okay, next 0 3. 0 3 is y axis. So here is a 0 3. Next 4 1. 4 and 1 is here. 4 1 3 4 1 2 2. 2 and 2 is here something. 2 2. Okay. So now what we have observed here, so they are parallel. They are parallel. Okay. So this is our 0 2. This is our 2 1. And this is our 4 0. Okay. What we have observed here, here both lines, here both lines never intersect each other, never intersect each other, never intersect each other at any point, at any point and anywhere, anywhere. Okay. Anywhere, that is, they are parallel, they are parallel, they are parallel. So it has no solution, it has no solution, it has no solution, and they are inconsistent, they are inconsistent, because अगर कोई solution नहीं है तो inconsistent है, they are inconsistent, consistent, they are inconsistent. Okay. They are inconsistent. Okay. They are inconsistent. So they are inconsistent. Or here is a one solution, so it is consistent, it is consistent, it is consistent, it is consistent, or it is, they are inconsistent. Okay. So you have these are two examples where we have discussed about these two. Now take an example of, I'm writing it, you will pause this video and write down it. I'm taking a third example, so I'm here the third example. So taking a third example, taking third example, so example number third. Example 3. Example 3. Example 3 is 2x 2x plus 3y is equal to 9 and 4x plus 6y is equal to 18. Okay. So now we are writing a ax plus by plus c form. So here through x plus 3y minus 9 is equal to 0 and 4x plus 6y minus 18 is equal to 0. Okay. Compare with compare with a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay. So a1 is equal to 2, b1 is equal to 3 and c1 is equal to minus 9. Again, and a2 is equal to 4, b2 is equal to 6 and c2 is equal to minus 18. Minus 18. Okay. A2 is equal to A1 is equal to 2, B1 is equal to minus B1 is equal to 3, C1 is equal to minus 9, A2 is equal to 4, B2 is equal to 6 and C2 is equal to minus 18. Now here take a ratio. A1 upon A2 is equal to 2 upon 4 is equal to 1 by 2. B1 upon B2 is equal to 3 upon 6, that is 1 by 2, and C1 upon C2 is equal to minus 9 upon minus 18 is equal to 1 by 2. Here A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. This is a algebraic result. Algebraic This is algebraic result. Okay, now take a graphically graphically so now take a graphically, what we have right here, 3y is equal to 9 minus 2x. Now here 9 minus 3x, so y is equal to 9 minus 2x upon 3, and the second one is 6y is equal to 18 minus 4x, and y is equal to 18 minus 4x upon 6. You will common the 9 minus 2x upon 6. This becomes 3. So y is equal to 9 minus 2x upon 3. You can observe that the both things are same. Okay, the both are same. Okay, so now here x and y x and y x and y. Okay, so let us do here. So when we put, now here we put the value which is divisible by 3. Okay, the number when we put the value of x, what we get, that is the numerator is divisible by 3. So when we put the x is equal to 0, y is equal to 3. Okay, 3 2 ja 6, 9 minus 6 is 3. So when we 3, that is 1. Okay, now here when we put minus 3, so 3 3 ja 2 3 ja 6 minus 3, so what we get, 5. Okay, so let here again same thing because the number are same. Okay, now when you have observed that this equation is multiple of 2x plus 3y is equal to 9, when we multiply by 2 in equation 1, this is equation 1. Okay, when we multiply 2 in this equation 1, we get a equation 2. Okay, so now draw graphically. So here is a graphically So 0, 1, 2, 3, 4 and 5. Here is 1, 2, 3, 4 and 5. Y-axis. Here is x and x dash. -1, -2, -3, -4 and -5. Okay. So here is 1, -1, -2, -3, -4 and -5. Okay. Let's do here. This is 0. So 0, 3. So here is a 0 and here is a 3. 3, 1. 3 is here and 1 is here. 3, 1. -3 and 5. So -3 and 5 here. -3 and 5. You will draw it. Okay, here, okay. Now, what we get the, again same thing here. So again the things are same. So you will make it dark portion. You will, I will make it the blue marker. So this blue marker is also going through this one. The blue marker is also going through this one. Okay. So here is the overlap. So they are overlapping each other. They are overlapping each other. Okay. So what we have observed algebraically here, here both lines, here both lines coincident, both line coincident, and both line coincident, that is overlap, lap each other, overlap each other, overlap each other. It shows, it shows that, it has infinite number of solution. It has infinite number of solutions. Infinite number of solutions. It has, it shows that it has infinite number of solutions. So it is consistent. So it is consistent. It is consistent pair of linear equation. Consistent pair of linear equation. Consistent pair of linear equation. It is consistent pair of linear equation. Here both lines coincide, that is overlap each other. It shows that it has infinite number of solutions. So it is consistent pair of linear equation. Okay. So what we have observed algebraically, okay, in the next video I will uh, put us I will make a chart of the algebraic and geometrical interpretation of pair of linear equation into two variable. Okay. Now you will go through these examples and think about these graphically and algebraically. It is so important for you for exam point of view, or for your NTSC's Olympiad maths. Okay. So you will pause this video and go through it. And the next video I will discuss about the chart of this algebraic and graphically interpretation. Okay. Thank you.